Hi students, in this lecture I am going to discuss how to calculate moment of inertia in case of a square plate, cylinders, spheres and cones. Let us see first one, square plate. Or before going for square plate, take rectangle. Let us take it is a rectangle. So take a rectangle, distribution of mass uniform, mass is m, length is l, this is l, and breadth is b. Okay. So we are taking one axis. Let us take we are taking one axis parallel to two sides. Let us call it as x-axis, and other one is y-axis. Again, parallel to two sides. So about x-axis, see what is I value. Ix equal to. When you want to find out along x-axis, this plate can be taken as a combination of number of rods, each of length b. I am repeating. This plate can be taken as a combination of number of rods, each of length b. Okay. Then this axis is a passing through center of the rod and normal to length of the rod. So this can be taken as m b square by 12, right? Because this is passing through center of the rod and normal to length of the rod. In the same way, if you want to calculate about y-axis, again, this can be taken as a combination of rods, each of length L. Then this is passing through center of the rod and normal to length of the rod. So this will be ml square by 12. Now by using perpendicular axis theorem, we can write Iz equal to Ix plus Iy, right? This is now m by 12 into L square plus B square. Okay. Right. Now see what we can do for a square plate. For a square plate, L equal to B. So if you are taking L equal to B, then see what happens. For square plate, L equal to B, then Ix equal to Iy, that is equal to ml square by 12, right? And what is Iz? It is ml square by 6, sum of those two, right? So once we are getting for rectangle, we can take directly for square by equating L equal to B. Okay, right. Let us see next what we have to calculate. So we have to take for cylinders, right? First, let us see hollow cylinder. For a hollow cylinder, for a hollow cylinder, first consider axis. Axis is a passing through center of mass and a parallel to length of the cylinder. Axis is passing through center of mass and along the, or you can say parallel to length of the cylinder. You can see this is a combination of rings, and for each ring about its own axis, it is mr square. Therefore, for this I value, directly we can say mr square. Okay, right. Now consider Axis passing through center of mass. Axis passing through center of mass and normal to the length. Okay. Now see what we can do. So we can take now combination of rings. Once again, combination of rings. Let us take at some distance x, element of length dx. So we are taking a ring of thickness, or you can say width equal to dx. Okay. So for this ring, about this axis. So we can use now parallax theorem. I'm writing di equal to, by using parallax theorem, distance equal to x. So writing mass dm into x square plus plus see about its own axis. That means we are taking now, this is a parallel to diameter, right? This is a parallel to diameter. For a ring, about diameter value is, about diameter, its I value is dm into r square by 2. Okay. Like this, we have to consider all rings from x equal to 0 to L by 2 and 0 to minus L by 2. Then we have to integrate. So I equal to integration of dm into r square by 2 plus dm into x square. Okay. Right. Now see calculation part. In this, we can see dm value. Dm equal. Let us take mass per unit area. That is m by surface area will be 2 pi r L, right? Surface area 2 pi r L. So mass per unit area. Okay. Into corresponding area. Corresponding area how much? It is corresponding area is now 2 pi r into dx. Okay. See, when you are taking the ring, its a surface area. It is equal to how much? 2 pi r into dx. Let us take now calculation here. Let us take first part, that is r square by 2 integration of dm plus integration of, now substitute this value in that 2 pi r gets cancelled. It is now m by l into dx, m by l into dx into what else left here? It is x square, limits minus l by 2 to up to l by 2. Integration of dm, that gives us total mass. Okay. So it is now m r square by 2. It is m r square by 2. Next, we can take m by l outside. X square dx, it becomes x cube by 3. X cube by 3. Right. Then see what we get here. Calculation part. X, it is L by 2, L by 2. I can take 3 outside. M r square by 2 plus m by 3l. It becomes now L cube by 8 and again L cube by 8. It is now 2L cube by 8. Okay. And 2 here 4 times. This is now ml square by, so mr square by 2 plus, and 1l gets cancelled here. Remaining is now ml square by 12. Okay. That is moment of inertia about an axis passing through center of mass and normal to length of the cylinder. Okay. For example, same thing given like axis is now normal to length of the cylinder, but passing through one end of the cylinder. Okay. See where change comes. Change comes only while taking limits, right? Instead of taking minus L by 2 to L by 2, we take 0 to L. Okay. That means here you can guess the answer directly. I equal to mr square by 2 plus ml square by 3. Okay. That is about hollow cylinder. Next, we have to focus. It is solid, right? See now for solid cylinder, almost same calculation. It is now solid cylinder. First one, so taking axis along the length passing through center of mass. Then it is a combination of circular plates. So it becomes now mr square by 2, right? Combination of plates. For each plate, mr square by 2. Then sum of all these things. Then we get total mass r square by 2. Let us take now. Axis is passing through center of mass and normal to length of the cylinder. Right? Passing through center of mass and normal to length of cylinder. Take at some distance x element of length dx. So almost same calculation. So we are taking a disk of thickness dx. Okay. Now for this we are taking parallax theorem. This is a parallel to its diameter, right? This is parallel to its diameter. Therefore, di di is equal to dm into x square plus dm into about diameter for a disk. It is mr square by 4, right? And in this dm, since it is now solid cylinder, we should take mass per unit volume. That is, volume is now pi r square L, right? That is volume into volume of this plate. Volume of this plate is now pi r square into thickness. Thickness is now dx. So pi r square gets cancelled. This is now m by L into dx. Right? So almost same calculation. Now integrate. So I equal to integral dm into r square by 4 plus m by x into dx into x square. And let me take here brackets. Next, you can take r square by 4 outside. Integration of dm, that gives total mass. So it is m r square by 4 plus, here you can take m by L outside. Integration of x square dx, x cube by 3. X cubed by 3, same calculation, right? Limits minus L by 2 to L by 2. So mr square by 4 plus this becomes how much? Again, it is m by 3L. It is L cube by 8 Again, same. So 2 times because L cube by 8 plus L cube by 8. And 1 is a cancelled here. This is a 4 times. It is mr square by 4 plus ml square by 3 fourths 12. Right? It's almost same calculation. Now, if we consider axis passing through one end of a cylinder, one end of cylinder, again same calculation, only changes while taking limits, we take 0 to L, okay? Then we are going to get I value mr square by 4 plus ml square by 3, right? So it is very simple one and direct one. Okay. Let us now focus what is next one. Next one is it is a hollow sphere, right? Let us see how to calculate for a hollow sphere. For a hollow sphere. So we are calculating for a hollow sphere about any diameter. It is about any diameter. Let us take now this is the diameter because about any diameter distribution of mass will be the same. Okay, about any diameter. This is hollow sphere. Hollow sphere. See how this is taken. This hollow sphere is taken as a combination of rings. Okay, let me see how to take rings. If you remember calculation of center of mass in case of hemispherical shell, okay, how we have taken limits almost the same, right? In fact, same calculation only. So we are taking now. So we are taking now. Let us take some angle theta with one diameter. Take angle theta. It is now d theta, small change. If you rotate now this one about this axis, if you rotate this one, we are going to get one ring. We can say the tip of this radius traces one ring. Okay, a ring of radius, it is r sine theta. Radius how much? R sine theta. Let us calculate mass of that ring because it is now combination of rings. For each ring, you can see this diameter is now passing through center of the ring and normal to plane of the ring. Okay. So what we can do is here di is equal to di is equal to dm into r square. R is now radius of that ring. That is r sine theta. Like this, we have to take all rings and we have to integrate. So integration of this. Okay. That is I. Now in this see what is a dm? Dm. Hollow sphere means mass is the only on surface. So we take now mass per unit area. Okay. So m by 4 pi r square. That is mass per unit area. Now area of this ring. Okay. Its length is 2 pi r sine theta. Length 2 pi r sine theta. That is length. Its thickness is now r d theta. That is now corresponding area. So in the previous one, we have taken 2 pi r into dr, right? Exactly same logic, 2 pi r into r d theta, right? Anything cancels here? 2 times. pi r. Here r is that r square cancelled, pi cancelled. Remaining what else left here? M. M. 2 is over pi over r over, right? 2 left here. Pi over r square. R into r square is over m by 2. M by 2 sine theta d theta. Sine theta d theta. Right. Now simplify this. Then see what we get. I equal to. So we can take here m by 2 outside. Here r square is there. Take outside m r square by 2. Taking outside. Remaining is now here sine square theta. This is now sine theta d theta. Okay. It is now sine theta. See, in the place of a sine square theta, we are writing here 1 minus cos square theta. Okay. In the place of sine square theta, we have taken 1 minus cos square theta. Now simplify this. M r square, or do one thing, take it separately. Calculation of this. See what we get, integration of, or continue like this only, m r square by 2. This calculation, integration of sine theta d theta minus integration of sine theta cos square theta d theta. We have two parts here. Let us now calculation see properly. We know for sine theta d theta, right? It is minus cos theta, right? Next, coming to the second part, how to calculate this, okay? For second part, if you know mathematics, that integration part, directly you can write. If you are not knowing that, okay, you can take like this. So calculation of this part. So what I am saying here, let us take cos theta as x, okay? I am taking separately integration of sine theta cos square theta d theta. Let us take in the place of cos, it is x. Suppose cos theta is x. We want here d theta, so differentiate this. Dx equal to minus sine theta d theta. Now substitute that here, okay? Substitute that now here. Then see what we get. Sine theta. In the place of cos square theta, x square. In the place of d theta, see what we can write? Minus dx by sine theta. I hope you are getting this. Sine gets cancelled. Okay. So what else left here? This continuation part, that is equal to minus x square dx. Minus x square dx. Integration of that. That is equal to minus x cube by 3. Okay, no? Here x means cos theta. Minus is there. Already having here minus. Minus of minus, it is a plus. Plus cos cube theta by 3. So finally what we got? Minus cos theta plus cos cube theta by 3. Now take limits. Like this, we have take all rings. From where to where? From 0 to 180. Then we get all rings. So limit 0 to pi. Okay. Then we are going to get this value how much? After simplification, we are going to get 2 by 3. Remaining calculation you can do here. So 2 by 3 pi r square. Okay. So moment of inertia for a hollow sphere about any diameter. is 2 by 3 mr square. Suppose question is now about any tangent. About any tangent. We can see any tangent will be parallel to diameter of the sphere. Okay. That means we can write about any tangent. T stands for okay tangent. Since it is a parallel to diameter, we can write parallax theorem. That is 2 by 3. 2 by 3. So it is now not pi, it is m, right? 2 by 3 mr square. 2 by 3 mr square. So 2 by 3 mr square plus between these two axes, separation equal to r plus mr square. So how much it is? 2 by 3 plus 1, 5 by 3. 5 by 3 mr square. So for a hollow sphere, about any diameter, its value is 2 by 3 mr square. About any tangent, it is a 5 by 3 mr square. Okay.